still. Good afternoon. Can you hear me? Good afternoon. Can you hear me? Yes or no? Just type in the comment box. Good afternoon. Okay, I'll start then. So I hope you remember what we did in the last class, right? We talked about current in the last class, and just to recap, first of all, right? Current. What is current? Current is the flow of charges. Flow of charges gives rise to current, right? Now these charges can be positive or negative, right? In metals, these charges are electrons, free electrons, right? In liquids, it can be electrons and not electrons, sorry, they are ions, right? In liquids they are ions, and in gases they are electrons plus ions. Okay, so this was the introduction, right? The formula for current is amount of charge flowing in per unit time, right? Amount of charge flowing per unit time. Okay, so where delta q, well, delta q is the amount of charge flowing through an area in time interval delta t, right. So this is delta q. Now unit of charge, this is charge, so it will be coulomb. Unit of time is second. So unit of current you can say coulomb per second, but this is given a special name. This is called ampere, right, you all know. So this is called ampere, right, and it is denoted with capital A. Okay, so unit of current is ampere, okay, and denoted with capital A. Now we studied also on that day, we also studied that a conductor, a metal conductor has large number of free electrons, right. A metal conductor has large number of free electrons which are constantly moving, but the motion is random motions, right, random motions, such that the net displacement becomes 0, right. That's why your current is 0. Now how can we get current from this? We have to connect it to a battery. We have to connect this to a battery, right. And now what is the job of a battery? The job of a battery is to supply potential. So that potential is written with capital V. Now once you supply potential to this, an electric field will be generated inside this conductor, and that electric field is given by this expression, right. This is the electric field that is generated inside the conductor. Formula is V by L. What is L? L is the length of this conductor. Okay, and because of this electric field, now the electron will accelerate, and that acceleration is given by E times, right. So this is the, and there is a minus sign here, okay. This is the acceleration of the electron, and because of the acceleration they will acquire average velocity Vd, and that Vd is equal to E m times tau, right. Okay, so this is the formula for Vd. Again there is a minus here, right. What is this Vd called? This Vd is called the drift velocity of the electron. Okay, this is called drift velocity, and this symbol here, if you can see, this tau is called relaxation time. Is called the relaxation time, and this is the time, average time between two consecutive collisions, right. Because when the electrons are moving through these conductors, they will collide with the positive ions that are inside. So the average time between two consecutive collisions is called tau, the relaxation time. Okay, so this is the velocity, average velocity acquired by the electron. Negative sign here shows that the direction of Vd and direction of E is opposite to each other. Okay, so I think till here we had discussed on that day. Any doubts till here? Any doubts till here? Do you have any doubts? Is any doubt still here? Everyone is clear so far, right? Today, that day I forgot to tell you about the unit of current. Please remember the unit of current is ampere, and it is written with capital A, right? We do not write coulomb per second. Never write coulomb per second. Always it will be ampere, okay? Denoted with capital A. Also, I told you on that day, current is a scalar quantity. Current is scalar quantity. even though it has a direction, right? We know that it has a direction. And what is the direction? Direction is from positive terminal to negative terminal, right? So the direction of current is from positive terminal to negative terminal, which I can show here. So positive to negative. Okay, even though current has a direction, it is still a scalar quantity, because if you want to add or subtract the current at a point or going inside of somewhere, then we have to use simple algebra and not vector algebra. Okay, so I think we discussed till here. If you don't have doubts, then we'll continue today. Okay, so what we are going to do today, we are going to find a formula for current, and we'll make use of Vd. Okay, we'll make use of Vd. The formula that we know so far is delta Q by delta T, right? But we will try to find another formula where there is Vd. We will try to find a formula of current based only on the parameters that are inside the conductor, right? Like Vd is something that is happening inside, E is the charge, and like that. Okay, we will use those and we'll try to find a formula. Okay, so here I have drawn a circuit. I have a conductor whose length is small l, and I have connected this conductor to a battery which supplies a potential difference of V, and because of this potential difference, an electric field will be generated inside this conductor, and that is given with capital E. The relationship between E and V is something like this: E is equal to V by L, right? So remember this formula. Okay, this is the relationship between these two. Now because of this electric field, the free electrons that are inside this conductor will start to move opposite to E, right? And opposite to E. So if you can see this inside, right? If you can see inside this one, right? So this is I'm showing an electron, it's moving with a velocity how much? Vd, right? Vd is a vector. Vd is a vector, right? Okay, so diagram is clear to you, I hope. And what is A? A is the area of cross section. Okay, A is the area of cross section, right? That means the area of this region here, this circle here, this if the conductor is like a cylinder, then it will be the area of this circle here, right? Okay, A is clear to you, I hope. Now how do we start? So so let us write down a formula for Vd first. What is Vd? Vd is equal to E tau by m, right? This is the formula, right? And here I did not write the minus sign because I am concerned only about the magnitude. I just want the number, I don't want the direction. When you are writing a vector formula, when you are writing in vector form, then you have to write the minus sign also, please remember. Okay, now so A is the area, L is the length of this conductor. Let us consider any electron inside moving with average velocity Vd, drift velocity, and that drift velocity in terms of E, and all this is this one. Okay, now if you don't know what is m, m is the mass of electron. Okay, m is the mass of the electron. So okay, so this is this now okay, so if A is the area of cross section and L is the length, then volume of the conductor, volume of conductor is equal to A into L. Okay, this is geometry. Okay, by geometry you know that area of a cylinder, not area, sorry, volume of cylinder is equal to area of this circle here multiplied with the length h. If h is the length, then multiply the area with the length, you will get the volume, and that's why you write pi r square h, right? This is the volume of a cylinder. Pi r square, what is pi r square? Pi r square is actually the area of this circle, or any circle on the above one or the below one, anyone, right? And you multiply that with the height, you will get the volume. So I'm doing the same thing here. I'm not expressing it in terms of pi r square, but A is the area, right? A is the area of this circle, and if I multiply with the length, which is L, I'll get the volume of the conductor, right? So that is that. Now okay, so let us say, let n, small n, be the number of free electrons in the conductor per unit cube, right? In one unit, in one small unit cube, the number of free electrons is small n. Okay, the small n is the number of free electrons that is there inside this conductor in a small unit cube, right? Now, so to find the total number, so therefore total number of electrons in the conductor, right? So how can you find the total? See, small n is the number of free electrons where in one small unit cube, in a small unit cube, right? In a small unit cube. So if I want to find the total, then what will I do? I will multiply this n with the total volume, right? If I want to find the total number of free electrons in this conductor, I will multiply the small number n and multiply with the volume of this conductor. So that will be equal to n times a l. This portion is clear or not to everyone? Any doubts till here? Any doubts till here? If you don't understand anything, just ask. Okay. Yes, any doubts? It's clear to everyone? Till here it's clear? Total number of electrons is clear? Total, how I found the total number of electrons is clear to everyone? Okay, so this is the total number of electrons. Okay, inside this conductor, total number is small n multiplied with the volume. What is small n? Small n is the number of electrons in one small unit cube, right? So that is how I got the total number of electrons. Now, so that is the total number of electrons. So to find the total charge, so how will we get total charge? Total charge, let us call it delta q, or no, let us call it, yeah, let us call it delta q. Okay, delta q will be how will we get that? Multiply this is, so this is the total number of electrons, right? This is the total number of electrons, and if I multiply this with the charge of one electron, if I multiply this total number of electrons with the charge of one electron, right? If I multiply this with the charge of one electron, then I will get the total charge, right? So that's how I'll get, so E into N A L, right? So this is the total charge that is there inside this conductor, right? Inside this conductor, the total charge is E into NaL, right? Is it clear? Okay, so this is the total charge. Now, okay, so you know formula for current. We know current I is equal to delta Q by delta T, right? We know this, charge divided by time. Okay, now what is delta T? Delta T is the time taken by the electron to go from this end, to go from this corner to this corner, right? Is the time taken to go from this corner to this corner. How will we get that? So you know the formula for time is equal to distance by speed, right? Distance by speed. So that distance is L in this case, and the speed, the electron is moving with an average velocity of Vd, right? This part is clear or not? Just tell me. This part is clear, or any doubts? Good afternoon everyone. Yes, are you able to understand anything? Please type. Yes, any doubts? Any doubts? Okay, so I'll assume you have understood. So now if I put the values, right, so delta q we got how much? This is the value of delta q, right, and that is your delta t. So if I put the values, so your I will be equal to E n a l divided by L v d, right. So this is, if you can see, right, this is I've just put the values. Now this v d will go up here, right, so I will get E n a l v d divided by L. This L will cancel out with this L, and my answer is E n a v d. So this is the formula for the current. Okay, now you look here, all the terms. E is the charge of an electron, n is the number of electrons per unit volume in the conductor, a is the area of cross section, and Vd is the drift velocity of the electron, right. So all the terms are the microscopic parameters. So we have found a relationship for current based on the microscopic parameters. Okay, so this is a very important relation, we will constantly keep using this. Okay, any doubts here? Anything that you want me to explain again? Yes, please type in the comment box if there's anything you want me to explain again. So I'll start again just once more. So Vd, this Vd is the drift velocity of the electron inside the conductor, right. Now conductor that I have taken has a length of L and the area of cross section is A. So the volume of the conductor will be A into L, right. So this is the volume of the conductor. Volume of the conductor is A into L. Now I'm saying that let n be the number of free electrons inside the conductor. Okay, so small n I have taken as the number of free electrons inside the conductor per unit cube. In a small unit cube, number of free electrons is small n. So total number of electrons will be how will we get the total number of electrons? Multiply this n with the total volume, right. If I multiply this with the total volume, I will get the total number of electrons, and that is n into Al. And to get the total charge, because you know the formula for current is delta q by delta t. So if I want a total charge, then I have to find, if I want a total current, then I have to find the total charge flowing in delta t time, right. So total charge I can get by multiplying this number of free electrons with the charge of each electron. So that is this one. So I will be equal to delta q divided by delta t. What is delta t? Delta t is the time taken by the electron to go from to flow from one end of the conductor to another, right. The conductor has a length L and each electron is moving with velocity Vd, right? So using the formula, simple formula, time is equal to length by speed, so length by Vd. Okay, so I have done that, put the values here, and ultimately I got this. Okay, so this is the current formula. Okay, all the things I think is clear here. E is the charge of electron, your n is the number of free electrons per unit volume. A is the area of cross section, and Vd is the drift velocity. Okay, any doubts? Any doubts? Okay, so next thing now, I will go to current density. Current density. What is current density? It is denoted with small j, right? And it is this is defined as the current per unit area, right? Per unit area, current per unit area, and therefore J will be equal to, by definition, I divided by A. Okay, just now we found a value for I, which is NEAVD divided by A, right? So answer is NEVD. So this is your current density. Okay, and current density is a vector quantity. Vector quantity. Vector quantity. Okay. Current density is a vector quantity. Right, and in vector form you can write this NEVD. Okay, this is your current density. It is the current per unit area. Okay, so that is that. Now next thing we will do is Ohm's law. We'll try to prove Ohm's law using whatever we know. Okay, Ohm's law you have done in class 10. It is V is directly proportional to I, right? For a conductor operating under a battery V, right, potential V, then the current flowing through this conductor will the current flowing will be directly proportional to the applied potential difference, provided the temperature and other quantities remain same. So okay, we'll try to prove that. So how do we do that? So okay, so I is equal to NEAVD. Okay, now we'll try to find this. Okay, so Vd you know is a drift velocity, Vd is the drift velocity, and its formula is E m by tau, right? Now I told you if V is the applied potential difference, then there will be an electric field acting here, and that is E, and the formula for E is V by L. So Vd I can write in terms of potential E V tau by m L, right? I'm just putting the formulas here. So now if I put this formula for Vd, if I put this formula for Vd here, right, so that will be equal to I is equal to N E A, Vd is how much? E V tau divided by m L, right? So now I'm just rearranging V by I. V by I will be equal to how much? It will be equal to m L N E square A tau, right? So this is your thing, right? Now if you look at the right hand side, everything is a constant here. M is a constant, it is the mass of the electron. L is the length of the conductor, which is also a constant. This is constant, right? Now N is the number of free electrons per unit volume, which will be a constant. E is the charge of electron. A is the area of the conductor cross section, sorry, and tau is the reaction time. That will also be a constant provided temperature is same, right? So for constant temperature, for constant temperature m L N E square A tau is a constant, right? So therefore V by I will be equal to a constant, and that constant we call resistance, right? This constant is called resistance. Right, so now if I rearrange, this will be equal to IR, or I can write V is directly proportional to I, which is Ohm's law. Okay, so this is the Ohm's law. Any doubts, please type in the comment box. All those who have typed their roll numbers after 140 will not get the attendance. Okay, only till 140 I have allowed. Others were sleeping, so they will not get the attendance. Okay, any doubts? Any doubts? Anything that you want me to explain again? Okay, so that is your Ohm's law. Okay, I have derived Ohm's law from the values of, from the expression for current. Okay, so that is your Ohm's law. Now next thing I want to do is, okay, so if I have a conductor of length L, and if the area of cross section of this is A, if A is the area of cross section, now you know this from your class 10 days, there is a relation that the resistance will be directly proportional to L by A, right? This is from your class 10 days, you must have done this. If I have a conductor of length L whose area of cross section is capital A, then the resistance of this conductor will be directly proportional to the ratio of L by A, and if I remove the proportional sign, I get a constant, and that constant is rho, right? This constant rho, it is a Greek alphabet RHO, rho. It is called resistivity. Right, resistivity. Okay, so we will try to find an expression for that. Now from here, your R is equal to m L n E square A tau. Okay, so this is your expression for R. Now we will use this here. So any doubts so far? Any doubts? So I will put this here. So R is how much? E square rho L by A, right? So now let us solve this. So rho is equal to, now this A will cancel out with this A, and this L will cancel out with this L. So rho will be equal to m n E square tau. Okay, so this expression you have to remember. Okay, any doubts here? Any doubts? Yes, any doubts? Okay, so now moving on. So that is your resistivity. Okay, rho is called the resistivity of the material. Okay, now what is the unit of rho? You can find the unit of rho from here, right? The unit of rho you can find from here. So rho will be equal to A R by L. So if I put the unit of A m meter square, R will be ohms, and L will be meter. So answer, so unit of resistivity is equal to ohm meter. Okay, and this is the SI unit. SI unit of resistivity is ohm meter. So that is that. Now next, so okay, so this is called resistivity. Now if I take the reciprocal of this, the reciprocal of resistivity is called conductivity. Okay, and reciprocal means what? 1 by rho. So this is called conductivity, and it is denoted with the symbol sigma. Okay, this symbol is called sigma, right? This symbol is a Greek alphabet again. This is called sigma. Okay, this is called conductivity. And it is the reciprocal of resistivity. Okay, so now okay, expressions for J. Just now we got J, right? Remember, if you remember, J is equal to NE times VD. This is your expression for the J. What is J? Current density. J is equal to that. Now if I put the value of VD, now VD, if you remember, is EM times tau, right? This is the formula for Vd. So this will be equal to n e square tau m e, right, and e has a vector sign. Okay, so this is your expression for J. Now just above we have learned that rho is equal to m divided by n e square tau, right? If you can see here, see this is your rho, and I will be putting this value here, right? If you can see, this is thing. Okay, so J can be written as E divided by rho. Okay, divide by rho, and just now I have shown 1 by rho is sigma, so another formula is sigma times E. Okay, so this formula I hope you remember. Right, any doubts here? Any doubts still here? Any doubts? Okay, what is J? J is the current density, I have explained on top. And what is J? J in fact is equal to current by area, current divided by area. So unit of J will be ampere per meter square, right? This is the unit, SI unit in fact of SI unit. Okay, and I found two different formulas for J. One is E by rho, another is sigma by E. Okay, any doubts? Any doubts anywhere? Any portion you want me to explain again? Please type in the comment box. Yes, any doubts? Sure, anyone, any doubts, please type. Okay, so I'll just give you a recap, right? So how did we start? So this is all yesterday's thing. I was just giving a revision here. Okay, now I was trying to find a formula for I, current, right? So I took a conductor whose length is small l is the length, and the area of cross section is capital A, and this conductor is connected to a battery which can supply potential difference of capital V, right? And because of this potential difference I get a electric field, and the relationship between electric field and potential is this one, E is equal to V by L, where L is the length. Okay, now we already know the formula for drift velocity is this one, right? And okay, so how did I start? Find the volume of this conductor. What is the volume of this conductor? It will be area times the length. So area is A, length is L, so the volume will be A into L. Now let us say that the total number of number of free electrons in a small unit cube of this conductor, in a small unit cube of this conductor, the number of free electrons is small n. So if I want to find the total number of free electrons in this conductor, I multiply that with the total volume, right? If I multiply that small n with the total volume, I'll get the total number of free electrons. I should write here free electrons. Okay, So that is the total number of free electrons, and to get the total charge I have to multiply this number, this NaL, with charge of 1 electron, right, which is small e, and the value is E is equal to 1.6 into 10 to the power minus 19 coulomb. Okay, so that way I can get the total charge. So to find the current I have to do this total charge divided by the time, right. So total charge I already got, but I don't know the time. The time here is the time that it takes the electron to go from this end to this end, right. If the length is L and speed is Vd, then your delta T will be L by Vd, speed distance by speed. So doing all that and putting the values, I got the formula for current, which is this one, right. So this is very important formula for current. We can find the value of current just by knowing the internal things of the conductor. E charge, this is constant, we know N is a constant, A is a constant. Just by knowing the drift velocity I can find the current. So this is a very important formula. Now next thing I defined was current density. It is current per unit area, so that's why current divided by area. So putting the values of current and all that, I got this is equal to this, and it is a vector quantity, right. In vector form you can write, this is the vector form, okay. And again so next I was trying to find the trying to prove Ohm's law. So far you have only studied the relation V is proportional to I, but you don't know the proof, right. So we're trying to prove that. So how did I start? I took again the same conductor, length L, battery V, and electric field E, right. So I is equal to NEA Vd, which we have derived above. Now I put the value of Vd we have done yesterday. If you don't remember, you can check that. Vd is equal to E times electric field divided by mass of the electron and relaxation time, which also we have done yesterday. Now E is equal to V by L, I have written here, right. I put that value here. So this is the relationship for Vd I get. Now I put this value here. After putting the value, I got this. I brought afterwards what I did, I arranged them. V by I will be equal to ml. You can do this. This is simple mathematics, right. V by I equals to ml NEA tau, right. And when I look at the right hand side, everything is a constant. M is a constant, L is a constant, N is a constant, E square is a constant, A is a constant, tau is also a constant for constant temperature, right. So this I can replace it with a small with a constant R, and that is your resistance. Okay, this constant is resistance. Okay, so from here I can show that V is directly proportional to I, which is Ohm's law. Okay, and we also found a relationship for resistance, which is ml n E square by A tau, right. Now looking at this, you can see that resistance of conductor depends on its internal things. It does not depend on the external factors, right. It depends on the internal factors. External factor, of course, temperature, it can change with temperature. We will discuss that. Okay, now next thing I defined here was resistivity. Resistivity you have already studied in class 10. R is equal to L by A. This is a relationship that you have studied for a conductor of length L and area of cross section A. The resistance is directly proportional to L by A. If I remove the proportional sign, I get resistivity. This is a constant, it's called resistivity, and this is a Greek alphabet, it's called rho, right, resistivity of a material. Now I know the expression for R from here. I put that here, and I got a formula for resistivity. This is the one. Now next, there is another thing that we have to define, that is conductivity. And what is conductivity? It is the reciprocal, that means 1 divided by the resistivity, right. That is called conductivity. It is denoted with sigma, Greek alphabet, and again putting the values I can get. Now again I went back to current density, right. Current density is, this is the expression we have derived above. Vd we have found is E by M times tau, right. Now putting all this here, I got this. Okay, and 1 by rho again is conductivity, so I have done that. Okay, any doubts? Any doubts? Any doubts? Yes, any doubts? Okay, so I'll stop here. If you want to rewatch it again, it will be here on YouTube, so you can watch it again. And if you have any doubts, you can ask me tomorrow. Tomorrow I'll take one more class. Okay, I'll inform you the time maybe later in the evening. I'll take one class. Okay, so for now I'll stop here. If you want to watch it again, you can watch it. It will be here only.